Myself, Srinivasan, working as a professor in the Department of Mechanical Engineering at Sri Sharma College of Engineering and Technology. In the last class, we discussed about activation function. Here, we are going to discuss about loss function. In the activation function, we will give you the predicted output. Here, we are supposed to calculate the difference between predicted and actual one. We can go by this way, and loss function from the regression model, a loss function from the classification model. Okay. So as long as you have a loss function from the regression model, we can go by these two metrics. One is mean square error, another one is mean absolute error. So mean square error is nothing but the mean of squared difference between the predicted and actual one. Okay. In case of mean square error, mean absolute error and the mean difference between the predicted and actual one. Okay. So the y hat is predicted one and the y is true mean actual one. Okay. Since we use only one sample, we don't need n value, so the loss is 9. Okay. In case of absolute error, it is going to be 3. Okay. So mean square error is very sensitive to outliers because since we are squaring the terms and it is going to be sensitive. So in case of small, if you have, as long as you have a small error, example, the difference between actual and the predicted is 0.1, 0.2 and all, and mean absolute error is greater than mean square error. Okay. Suppose if you have a large error, okay, 1, 2, 3 and all, and the mean square error is greater than mean absolute error. Okay. So as I said, the loss function we will go by classification model. There are many ways, and the best example for the binary classification is whether our Gmail is spam, whether the detected one is spam or not spam. Okay. So that comes under the category of binary cross entropy. So the number of output is going to be 1, because if you have a 1 neuron, we can say whether that email is spam or not spam. Okay. So as long as you have a multi-class classifications, okay. So if you look at the one, it is horse, okay, and this comes under the category of animals, okay. This comes under the category of animals. So the animal could be rabbit, dog, and everything. So it is basically a single label, and since it is a horse, so the prediction is going to be horse only, okay. So number of output is basically number of classes. Basically, as long as you have multiple classes since and horse, rabbit, dog, and all. So the output is going number of neurons in the output layer is 3. So if you look at the image, you have a cat, dog, bird, everything. Okay, you have a horse and everything. Okay. So this comes under the multi-label classification. So you will label many things in the same image. Okay. So this I can say it is a multi-label classification. So when you have binary cross entropy or log loss, this formula, the cross entropy formula, is derived from the Echelon theory. And what it does is basically it tries to find the difference between the true distribution and the estimated distribution, P and Q. Okay. So when we apply for the binary case, okay, true and positive and negative category, and true and predicted one, so we can use this formula. Okay. So if we expand that formula, then we'll have this one, and here we use the sigmoid activation function. Okay. So if you have more samples, okay, if you have more samples, but the category is 2, that is predicted, category is yes or no, true class and true class is 1 and another class is 0, then we can use this formula. Okay. So the first one is basically a positive class, and second term in the equation is a negative class. Okay. So as long as if you look at the formula, the minus sign is given because whatever the output that we get from the sigmoid function is 0, between the 0 and 1, and in order to avoid negative values, we put a minus sign over here. Okay. Suppose if we have the predicted one is 0.9, which is very close to the true class, the loss is going to be very small. Suppose if we have predicted one is predicted one is 0.1, you will have a large loss. So as long as you have a large one, it is confidently punish the things, punish the wrong prediction, we can say. So this is basically categorical cross entropy, and where in the binary one we use sigmoid function. Here we use softmax for the probability distribution. Okay, so the classes may be cat, dog, horse. All comes under the category of animals. The true class is dog. So what we have to do is we have to do one hot encoding. So what is a one hot encoding? Suppose if you have animal category dog, cat, rabbit, bird and all. So for the case of, for the ID 1, and if you find dog in the first place, it is going to be, you have to put 1 over here. Okay. For the second ID, you have to put 1 over here. So similarly, if you look at this, whatever is given in the example, and y is equal to, because the true class is dog, okay, and that's why it is in the middle. Okay, so whatever that we have predicted based on this from the model, it is going to be 0.2, 0.7, 0.1. Okay, so we can calculate the loss function based on this theory. This is going to be a multi-label problem. Okay, so you have a single sample, and what we have seen in the second slide, we have a cat, bird, everything. Okay, so you have a single sample, but many labels are there. Okay, in such cases we can use this formula, and in true labels 1, 1, 0, and predicted one is this 0.9 and 0.8, 0.3. So sun is there, sunset is there in the image, and beach is also there. There is no person over there. That's why it is put here. We have put 0 over here. Okay, as long as class 1, it is going to be very less. Then when the predicted one is very less, then the loss is going to be huge. So we have to combine for the all three classes for the loss classification. This is the most important topic as far as generative AI is concerned, because whenever we have a true image, when we generate an AI based image, and the loss can be calculated based on the scale divergence theory. Okay, so how much it calculates how much differs from the reference distribution. Okay, if you look at the probability distribution function for these two categories, the KL divergence between P and Q, and the red one is basically KL divergence P and Q, and the blue one is basically KL divergence Q and P. Okay, so we can have for the discrete values of I. In case of discrete values, we can use the summation sign over here, and this is a loss function, KL divergence loss function. And for the continuous value, we can use summation, integral sign over here. Okay, so based on that, we can able to calculate the loss function. So